this one? Oh, would you mind to lead the prayer already, Pawi? All right. Yes. All right. So thank you for that one. Yes, please wait. Huh? All right. So thank you for that one, Pawi. May I request to everyone to please open their camera for I will be having my initial screenshot. Thank you. All right. All right. All right. So, last meeting, no? It was Sunday, no? Ay, Sunday. Sorry, Tuesday. All right. So it was Tuesday. No, so we already had so we already had encountered. We already encountered about geometric sequence, right? Okay. So before we proceed to the next part of this geometric, may I ask from this class, what did we discuss in this geometric sequence? All right. So from anybody from this class? All right. Anybody? May I call on? All right. So let us have Joshua. Go, Joshua. Yes. Mm-hmm. Yes, but if ever you can open your notes, you can open your notes. You could check what your notes have.
Sir,
Yes, but
if the ratios of consecutive terms are the same.
all right. So we could say that a sequence is geometric if the consecutive ratios or the difference or if the consecutive terms uh, has a common ratio, no? So it is right. All right. So we have common ratio. All right. So in finding the terms, no? So may I call on? Yes. May I call on um, John Adrian if we have this common ratio, no? May I know what would be uh, the formula in finding the term, the nth
Common,
term,
common ratio po, sir.
the nth term?
And term wait.
Yes po.
Uh, and term po, sir.
Yes
Right?
po.
Uh, A1 times R uh, exponent n minus 1.
All right. So thank you for that one, John. All right. So that is correct, no? Grade 10. So I just want to add up, if ever, because um next time we will be having this kind of recitation, and in this recitation it will be graded, and if ever that I'll be asking you such terms, no, telling the expression or the given formula is really important. For example, we have that formula which is a sub 1, no, a sub 1 times the ratio raised to raised to n minus 1. Okay? So, John Adrian, is it fine already? Right? About that one, it should be raised. All right? Because it is exponent, yes. Okay, so discussing this one, kindly tell me if we are done with this slide. Are we done with this slide? This one. Did you stop here? Did you stop here? Yes. All right. All right. So we were able to find what is the explicit rule, no? So if we say explicit rule, this is our explicit rule. But if you are asked to find what would be the term, for example, I'll be asking you finding the term, which is 12, no? You answer this one, ah. If you were asked to find the 12th term, then that's the time that you will be substituting and answering it. Okay. All right. So the answer, the final answer would be 6,144. Disregard the x, ha. It should be A. All right. So we are now in a geometric series. All right. So I guess we already as well, we already discussed this as well, no? But for us to recap as well about the geometric series, no? This way. I just forgot to uh, indicate this one. So advanced math, page number 12. All right. So it is. All right. So for this one, no? So we have the summation notation. Yeah? So if we say summation notation, it only tells us to find the sum of all terms, no? So sum of first n terms, no? Or you could say that we are just finding the sum of all terms. Okay, so having this expression, all right, so we have the upper limit and the lower limit, which is n, which would be our upper limit, and lower limit will be the index, no? If we say index, it is the number of terms, all right? Okay. So, by the way, just to splice this moment, no? Um, is your section the one? Is it your section that asked me to post the PETA for calculus? No, not no. If ever, if I did that one, no, so I will be posting the PETA for calculus. Maybe I will try later, really, because Tuesday and Wednesday I did a lot of stuff. I'm making already the exam, no. So, anyways, with regards to your notes, I will be sending as well. What do you call this one? I will be sending uh the PETA for you to be able to know what are the things, no, that you should see. All right. So we have the upper limit. Going back, ano? Going back, we have the upper limit and lower limit of this summation. So this sign it is called as summation sign. What is this called? What do we call to this summation line? We called we call this sign as, right? There's no sigma. All right. So that is correct. So we have sigma. So it's called as sigma. The sigma of the upper limit, which is n, and the lower limit of I is equal to 1. All right. So, knowing that we have these parts, no, we should know how to use these parts. No, it doesn't, uh, it shouldn't be like we just know the parts, then we don't know how to use it. So how are we going to use it? For example, we do have this upper limit of 5, and the lower limit of this sigma would be n is equal to 1. All right, so for this one, from the given of 4, sigma notation of 4 raised to n, no, we will be having the upper limit of 5 and the lower limit of n is equal to 1. The sequence, no, the sequence, no, or the series that we will be having would be 4 raised to 1, if you will notice. 1, 2, 3, 4, 5. All right. So if we say 5 up until to the term that we are having for the upper limit. So it is called as limitation. If we say limitation, that is the end part where we should find. For example, that is the limitation of that sequence or series. Okay, so hanggang dun lang. Alright, so we will be having the series up until the fifth term. Okay, so we have the fifth term, no? Having their exponents from the value of the lower limit. So what is the value of our lower limit? N is equal to 1. So therefore, we will be substituting all the exponents to their terms. Alright? Okay, so now we will be having, no? Now we will be having 4 plus 16 plus 64 plus 256 plus 1024. And if we will be summing up, or if we will sum up these terms, we will be having 1364. Alright, so yes, at first it is a little vague, no, for us to have this introduction for geometric series, but no, but if you will try, no, to differentiate uh, what is the difference between two sides, no? So you could see what would be the easiest part on how to handle this sequence, this series, this arithmetic, this geometry. All right. So let us have this another given. No? So let us have the sum of finite geometric sequence. No? All right. So for the finite, all right, sum of the finite geometric sequence. So the formula for this one is this part. But it is also equal for this part. Okay. All right. So knowing that, all right. So let us have this kind of series. All right. So if you will be asked, all right. So what will be the sum of that part? All right. So we'll be having the n, or we have the terms, number of terms, no? So we have 8 terms. We have 1, 2, 3, 4, 5, 6, 7, 8. All right. And as well as we have the value of the first term. Okay. So after we have the first term, we got the value for r in the formula, right? So what are we going to do is to find what would be the common ratio, no? So having the common ratio, we know it already. The term that you are having, divide to the previous term of it. All right. So let's have the second term divided by 5, which it is the previous term. Then 10 divided by 5, it will be 2. Now we have the common ratio of 2. Now what are we going to do is to simplify. So how are we going to simplify and solve that one? So first is find what is the sum, no? So having the formula, always write the formula, do not forget. Okay. So after that one, we then simply substitute all the given. All right. So all the given, so we have 2 raised to n. All right. So if you will notice, this is the one. All right. What would be the a sub 1? It will be 5. What will be our common ratio? It will be 2. And our n will be 8. That's why 8. All right. So 2 raised to 8 will be, what will be the formula? Where's the our calculator? All right. So 2 raised to 8, 2 raised to, sorry, 2 raised to 8. Oh, what will be the answer? Hmm. The answer would be 256. All right. So we have 256. All right. It is correct, ha? If you will try to calculate it in your calculator, 256. All right. So we then subtract 1. We then subtract 256 to 1. Then we will be having negative 255. As well as we subtract the denominator, which is 1 minus 2, then the answer would be negative 1. So if you will be trying to divide this one, negative 255 divided by negative 1, it will be 255. No? Knowing that it is same negative, so it will be positive. Okay? So having 255, if you multiply 255 to 5, is it really 1275? So yes, it is. So if you multiplying that one 5 times 255, you have 1,275. All right. Okay. So next, sweet. All right. So here. All right. So the sum of terms of an infinite geometric sequence, no, is called geometric series. No, if it's infinite, no, infinite sequence, geometric series. No, if you have uh, this one, for example, please wait, please wait. So let us have no, this kind of geometric series. No, so if what do you call this one? If the absolute value of ratio is less than 1, then the infinite geometric series will be a sub 1 plus a sub 1 times r plus a sub 1 times r squared plus a sub 1 times r cubed and so on. No? If you will notice, it is only said that the ratio, if you say absolute value, if you will see this kind of bar, no, do you know how this bar works? Do you know in your class? Do you know? If we have this bar, if you saw this bar, it only means that whatever number you put in there, for example, give me a number, for example, negative 4 or 4, whatever number, is it positive or negative, whatever number you put inside the absolute value bar, the value that will be having is only 4. Whether it is negative or positive, it will be always positive. Okay? So if we say absolute, absolute talaga, yun talaga yun. Alright? So it's like there is a definite value. If we input any number, the the value would be always positive. Okay? Alright. So it is said that if the absolute value of ratio less than 1, no? Ibig sabihin daw, mas mababa daw sa 1, then we will be having this series. No? So, how is it, sir? You will be asking me. So, from this formula, because we will be having the sum, so we could tend to have this shorter formula instead of having this summation, no? Because it is really long. It has this infinite sign, no, and it is called infinite geometric sequence. And if we tend to have this kind of infinite solutions, it really takes time. That's why we end up with this kind of solution. All right, so let us try to have an example for this value, no, so that you will know how to use this formula. All right, so let us find the sum of this series. All right, so we have 3 minus 1 plus 1 third minus 1 9 or 1 9 plus the following terms. All right, so this is the series. So our ratio in this part, if you will notice, no, it says that if the absolute value of ratio is less than 1, so we could see at least this kind of series. You will notice what is our common ratio. It is negative 1/3. So it is lesser than 1. Okay, so as we have this value, no, we can now transpose or substitute all the givens that we have in order for us to have the sum. All right, so let us try that one. So we have a sub 1 is equal to, what is our a sub 1? It will be 3. Our ratio would be negative 1/3. All right, so having this formula, if we will be transposing that one, and substituting all this given, it will be 3. All right, our first term. our ratio would be negative one third. And if we will be solving that one, we will be having the answer of this one. All right. So when we have positive negatives to negative, no, we tend to have it as positive. All right. So when we add um, whole number to uh, a proper fraction, we tend to what? We tend to change this whole number to the same of to the value of the denominator, which is 3, 1. All right. So we simply add that one as 3 over 3. So we know that 3 divided by 3 is equivalent to 1. So when we add this one, we will be having 4 over 3. All right. So it is just the same. No? So if you will notice, there are other terms. I know you know this already. We just simply times this one. Oh, 3 times 1 will be 3 plus 1 plus 1. It will be 4. All the numerators are the remainder of the quotient in the long method of division. No? All right. So now we have the 4 thirds. All right. So my question is, could we find the answer in this term? No? So because we have 3 over 4 thirds. Okay. So having this one, how are we going to solve this one? Hmm. How are we going to solve this one? Do you have any idea? In algebra, you have any idea, my class? All right. So if you saw this kind of, for example, if you saw an expression given like a value or a given number 3, then a fraction bar, then below the fraction bar, which the denominator is also a fraction. If you see this kind of uh, given, what you can do is to eliminate first the numerator by what? Factoring that one. So how are we going to factor that one? We could simply put that one as 3, okay, 3 times 1 over 4 over 3, right? Right? So after this one, no? So we could also have, um, if I'm not mistaken, it's conjugate. No? So we could have this term, no? Mm, this way. Let us have 1 over 4 thirds multiplied by 3 over 4, 3 over 4. All right. So in this case, all right. So this value is just the same as 1, right? 3/4 divided by 3/4, the value would be 1, right? So if we try to factor or remove the denominator of fraction, no, we simply have this part, no, as 3/4, then 4, sorry, we could have this part, 4 times 3 times 3 times 4. And if you will notice, we could cancel this out, right? So we could cancel this one to this one, right? And also we could cancel this one to this one, right? Because if you will also times that one, the value would be 12. And lower part would be 12. And the answer would be there is 1. And and the final answer that we could see in that part would be none other than 3/4 all over 1. But we could simply say that it is just 3/4, right? Because any numerator, for example, when we multiply 4 times 1/2, what will be the answer in fraction form? Of course, we just multiply numerator to numerator and denominator to denominator. So when we multiply numerator to numerator, it will be 4 over 2. So as well as this one. So we will be having 3/4. No? So having the 4/3, no? Again, having the 4/3, we could now have, when we factor this one, we could now have 3/4. Right? So having this one, having this form, we factored 3 to the whole form, right? It's like 3 times 1/4. So this value is the same, this value, right? So this value a while ago, just the same as this value. So questioning me why again, how does it happen? We have the conjugate. No? If I'm not mistaken, that's the column. That what we did is we multiply by its reciprocal. Okay. So after having this 3 and 3/4, we could multiply the numerator, right? So we could say that it is 9/4. Okay. So from this one, may I know if 9/4 is the answer already? All right. So I'll just erase this one. Huh? Right. So if you will notice, okay, so I'll be showing you some answer. No? All right. So this is the way how it works. All right. So questioning me if 9/4 is the one? Yes, it is. So the sum of this series is 9/4. Okay. All right. All right. So from this one, we are now done in geometric sequence and series. No, the only thing you need to remember always is about the uh, arithmetic mean, sequence, the formula F, and no. But before that, also I would like to add up with regards to, let's wait, to some kind of sequence and series because there's a lot of things that you need to tackle. Alright, so grade can be equal. Mm, Alright, so let us have some short activity. Okay, activity this one ha. Ano eh? So how many are you? You are Carleal is not here, no? Only Carleal is absent. Okay, so you are 44. Ay, sorry. 10A. Yes. You are 46. So therefore you should be 45, no? So I will be sending a link. This way, Hannah. Alright, so from this folder, you will be sending me the activity, short activity that you will be having right now. No, this way. So may you ready your notebooks. So you will be answering right now. Alright, so will be fine. So please ready your book, notebook. Okay. Alright, so please wait. Is the presentation visible already? Yes po. Yes po, sige. So for those who have commercials, so I'll be giving you time. No, you have 6 minutes. Oh, 5 minutes, 5 minutes. 10:29 or 10:30, you should be here already, huh? Go, go, go. For those who want to go CR, wants to drink or whatever, go already. Finish your thing. By 10:30, we will be having our short activity. Alright, so it's 10:25 already. So while waiting for the others, may I just remind ka for what do you call this one? For the PETA. How many groups do you have? May I just ask? How many groups do you have? You have five. You only have five. How many members? Five plus three. Ano kalokohan? May 15. Grabe naman kayo. Right. It's fine. The others, please help the people who are assigned. No? So if you have roles, please do have it already. About that one, if you will be asking me, sir, because there is one. Is it you, Joshua, the one who asked me about the grading system? No. How will I grade your work? No. For that one, no. So um, it's like if you have this product, it's up to you. It's like, for example, you will be showcasing may I ask, Joshua, in your group, what product are you going to have in your group? Joshua, go.
Solar charger po.
Solar charger. Wow. Wow. So, so how are you going to do that one? You don't know. What's your role, ba? What's your role?
Project manager po.
Alright. So, project manager. Who's your engineer? Josh? Who's your engineer?
Po.
Who who's the engineer in your in your group?
Francis po.
Oh, so Francis, may I know? Alright. So where's Francis? So that I could guide you as well because maybe you'll be asking us, paano yan, paano yan, paano yan. Carlo Rivera, right? Francis, would you mind to tell us or share? There's nothing bad in sharing what's your product. Or there is a thing that you don't want to share that one. Is it that's the case? Is that the case, Joshua? You don't want to share? You don't want to share. Okay, how about the others? So who are the other project managers? Aside from Joshua. How about the others? Who are the other project managers? No one, only Joshua. I'm asking this one for I will be able to know, no? Because sometimes I don't have time to go back read in the GC, check the GC. Until now, I'm not yet checking who are the project managers in the GC. Just want to ask, no? Nathaniel, how about you? Who are your group mates?
The same as Joshua po.
Same as Joshua. Okay. How about Abigail? Who are your group mates?
Bernie, from 24 to 34 po.
24 to 34. Alright. So, what's your role?
I'm content writer po. Our project manager po is Bernice and then engineer Tea Del Val.
Okay. May I call on Gavero? Is it Gavero, no? It's Gavero, Bernice.
Yes po.
Yes, po. How was it? How's your product?
To be honest, sir, as a research pa lang po kami. And we're
Really?
done. And the product that we will be doing, I guess, is solar street lights as well.
Mhm. Okay. Alright. So how about the others? Thank you for that one, Bernice. How about Joey D? What group are you?
Group 4 po, sir. Class numbers from 34 until the last class number po.
All right. So who is your project manager? Mm.
Pawi po.
Pawi. So what is your product?
Sir, it's a water filter po.
Water filter. All right. So how is that water filter like? What's the difference of that water filter compared to the others? Does it have other uh, things that wala yung iba? Hmm.
Sir, sir,
Yes, ma'am.
may I
Yes, ma'am.
explain on behalf of Jody?
All right. Yes, yes, yes.
Uh, Instead of the water filter that will be connected to the faucet, it will be collecting used water. That we will filter used water. Ganun
Mm.
po. Instead of filtering unused water to be sanitized. Ganun po.
Okay. Sige, sige. Okay. All right. So, for this one, no, so if you will be asking me, sir, how are we going to connect arithmetic sequence and series into that part? No, so the reason why I interconnect to this subjects, computer, no, computer and English is that during our times there we have also like this one, and it's really fun to have this kind of it was like experimental research as well. So having the uniqueness of different groups is really great. It's really nice to see, and also how did they connect the subject to itself. In my part, you could have it more likely in designs. Could be, it's up to you on how will you connect the designs to the sequence, no, or somewhat for the tools that you did or the budget that you have. It's up to you. It's on the written, right, no, so you will be having your output where I will be reading that one as well, and how did you connect your project sequence and series, no, and what more, the designs, yes, I will be also dealing with that one because as I said, no, uh, design would be great, will be one of the factors uh, really in knowing what Carlier or in knowing what is the connection of that product, because even though for example it is really too far for the subject itself, no. Hello, Carl. May I know why you just entered late? I'm just asking. Alright. So just in case you're concerned, you could just PM me, ha? What's your reason? Okay. Yun. If your product is really that far to the sequence and series, you will fill that part into design because I give part for what should be in that project. No? Alright. So let's have this one. Please wait. Oh, alright. Sige po. Alright. So I understand the thing. Alright. So this week, ha. So the one that we will be doing, Carl, we discuss with arithmetic series, but more likely I will be asking for you to solve um, what 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 will be uh, our activity. So we will be having our activity right now. So for this time, let us now focus on arithmetic sequence. All right. So for this time, I want you to take note of the givens. All right. So please ready your um, notes already. So for the first given, this will be our first given. Take note of this one. I will be going to the next slide. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right. So for the next slide, this one. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right. So let us have the next slide. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So for the next slide, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Okay. So for now, I will be waiting until 10:50. So you could now start your work. No. So while doing your work, uh, just do your work. I will be waiting. I will be just doing some stuff for you. All right. I will be sending the link where you will be passing your work. Ha. All right. So for this one, this is the link. This week. Okay. Editor. Copy link. Done. All right. So if you are done, all right. So this is the drive where you will be inputting your answer. After you answer that one, take a screenshot, then pass it on the Google Drive. With this format, with your Google account name. We have 10A underscore, for example, 00, this is my class number, underscore, then full name. All right. Oh, yes. All right. So this is the first slide, Again, this is the first slide. First given. Okay. Second given. This is the second given. All right. So this is the third given. And this is the fourth given. All right. About your case, Carl, I should be giving some arithmetic mean, no? Did you encounter that one during our discussion, like last Friday? I last Tuesday, arithmetic mean. Do you remember arithmetic mean? Yes. All right. How about Carlea? All right. So that would be your activity for this day, no? And so for hmm, all right. So just tell me if you are done already, All right. So first slide po tayo. So this is our first slide. Okay. All right. So we are to find this one. So we have n. We sub 1 is it? Okay. All right. I will give you time. By the way, if you are done already and you're done in passing that one, type in the comment section you are done already. All right. As I record your things in here, we are done with three. Okay. Ah, yes, there is four. Four. I'm sorry, there is four problems. You only have this one has four. Yes. So find the 25th term. So we are to find AN. Yes po. Sige. So while I am recording, because we have already some of the lessons now. Hmm, okay. 10. This is 10A. Alright, so how about this one? So are you finished already? 2 minutes left. Susyak ka. Oh, sige. Go. Mm-hmm. This one. Then this one. Oh, are you done? Yes. Okay. Fair point of view. All right. For that one, we have the Google Drive. This is the Google Drive again, ha? This is the Google Drive once again. All right.